Hi, welcome to Dr. Pat TV. In this video, we'll be playing with simple interest. We'll be looking at the main concept and the formulas that we use to calculate it. We do have two kinds of interest. One's this simple and one's compounding. And basically, if you look in this upper right-hand corner, simple interest is a straight line. When you're adding your account, if you're earning interest in an account, your account balance would go up in a linear fashion. Compounding interest, and we'll do another video on this later on, basically increases in a exponential format. So that's the key idea. Compounding interest is an exponential idea, and simple interest is a linear idea. Okay, so let's take a look at the formula. So get the idea first that interest, it's the money paid for the use of somebody's money. So that's the key thing when we're talking about interest, we're talking about money. So whether I receive the money when I'm putting my money in a savings account, the bank is paying me interest. If I have a loan from the bank, I'm paying them interest. So basically, it goes both directions, depending whether we're talking loans or savings. They're just basically different sides of the coin. Okay, we have two kinds of interest that we'd be playing with: compounding interest and simple interest. With compounding interest, I'll be doing a video later on this, but the key idea of compound interest is I'm earning interest on my interest. Whereas simple interest, you're only earning interest on how much you put in or the loan amount. And so the key pieces of simple interest are the interest rates. So that's either an I, or wait a minute, excuse me, I for interest, and then P for principal, R is for the rate, and so R is for the percentage rate, which will turn into a decimal, and then you've got T for time. Now, also, I just got to be careful about interest rates. Sometimes use I, so want to be kind of interchangeable, be flexible with the use of R or I. You just got to know which formula you're going to make. And I have to apologize straight up. There are so many versions of the same formula, whether we're using I's, R's, sometimes we use an N and then there's an M, and there's just all kinds of different things that we have here. And so you just got to be flexible and we'll get the idea across. Okay, so let's do an example here. The simple interest, it's calculated on a single amount. So how much interest is earned for a loan of $100 at 5% over 2 years? A couple or a thing that we gotta I gotta mention right here. Whenever given a percentage, if it's not stated the time period for the rate, then assume for the year. So our percentages will be given in terms of the year unless specified otherwise. So we're looking at $100 with an annual rate of 5% over 2 years. And if we're doing simple interest, then basically simple interest is, I for interest is PRT, the principal times the rate times the time. So we're talking about $100 is our principal. That's the amount borrowed or put it in for savings. Then we have 5%. I'm going to convert that 5% into a decimal form, so that 0.05. And then we're looking for a time period of 2 years, so then we're going to multiply by that by 2, because we're basically getting 2 payments of this interest, one for each year over a 2-year period. And so when you do that calculation, you get $10. So basically the amount of interest is $10. If I had to pay back this loan all at one time in the 2 years, then I would have to pay back $110. The $100, the amount I borrowed, and then the $10 for interest. And another key point I want to bring your attention to is that the rate and time, they need to be in the same time frame. So if my rate is in terms of an annual rate, then I better make sure that my T, the number of periods that I have, needs to be in the same time frame. So if my rate's in terms of years, then my time needs to be in terms of years as well. And so that's really important for later on, so you don't miscalculate that. Just keep in mind that rate and time, same time frame. Okay, so now some formulas for calculating interest, two versions that we have. We've got our calculating just the interest by itself, I for the interest, PV. You see the letter P for principal. We also have another version, PV, which is present value. So if you're taking your econ classes and things like that, PV is one of the things you'll see quite often. And then R for your annual rate, and then T for that time. Now, if I want to calculate my future value, this would be the amount that I have to pay at the end or how much I would receive. Then what we're looking for there is FV for future value. And basically what you're seeing here is PV is factored out. If I wanted to multiply this back through, PV times 1 would be the present value, and then PV times this RT, you're going to see that we would get back the interest calculation. So what we're looking at is this is a simplified version of the money that we started with, the present value, plus our interest rates. And so that's what we've got for future value. Okay, let's do another example here, and then we'll call it a video. Something called a bridge loan. Okay, so basically what we're looking at is that there's situations where you want to get a quick loan just for a short period of time in order to do some transactions, such as if you're buying a house, you're selling your house, you're buying another house, but you got to buy that house right now. So then what'll happen is the bank could charge you, or you can get a bridge loan. And what you would do is a very short, temporary kind of loan so that you can purchase your house based upon the idea they're giving you the loan, knowing that you're going to be able to sell your house that you have now. And so you just need a loan just for a short period of time to get you over the hump to get the things that you need. So it's called a bridge loan. All right, so let's do this word problem here. The bank's going to charge us 9.2 simple interest on a bridge loan of $240,000 for 60 days. How much will be owed in 60 days? Okay, so one of the key things I'm looking for when I do a word problem is I like to identify what I'm trying to find. In this case, FV, the future value. We're looking for how much will be owed. That's how much together the interest and the amount I got to pay back, the future value. Another piece of information we have here is the interest rate, 9.2%. Remember, we convert that into a decimal, move it over 2 decimal places. So to go from percentages to rate, 2 decimal places, so it's now 0.092 that I'll be using for my calculations in the formula. Another information we have is our 240,000. That's our present value. That's what we're getting the loan amount. You can also call that your principal. And then our time frame is going to be 60 days, but because my rate is a understood implied annual rate, what we have to do is we have to take the time to change that 60 days into a time frame of a year, and so 60 days in terms of a year would be 60 over 360. Okay, you might be wondering why I'm using 360. Well, let's wait till the next slide and I'll get you an example of that. All right, so now that I've got all my information, I've got my rate, I've got my time, I've got my principal or my present value. So now I'm ready to calculate the amount owed, the loan amount plus interest, and that would be my future value because it's got incorporated the loan amount, the principal, the present value, plus the interest, which would be this RT times PV. So kind of a condensed version of that. Just plugging in the numbers that we have, the 240,000, the 9.2%, the time frame within a year's period of time, and then now we're looking at 243.68. So at the end of the time period in 60 days, I need to pay back the bank that 243,680. And so that's telling me I've got an interest amount about 3,680 for that 60-day time period. That would be my amount of interest. Okay, so now let's finish this up by going, hey, why are they using 360 instead of 365? Well, let's take a look at that. Well, if you're the bank, how would you set up this system? Would you do 365 or 360 for the number of days in the year? Well, I'm a bank. I want to make some money. And so here's what's going to happen. So I'm going to use the same formula and we're going to do the calculation. The first one using the 360. We've done that. That's that 243,680. And then for the second calculation, let's use 365. And you're going to notice there's a difference of $50 there. So by using 360 days for the year, we actually get $50 more if I'm the bank. Now, if I'm the customer, I'd rather use 365 because then I'd pay back a smaller amount. It's all a matter of perspective. So now you may be thinking mathematically, what's the difference between 360 and 365? How are we coming up with that $50 difference? And it's all about fractions. Remember, when you're playing with fractions and you have a larger denominator, that means the overall value of the fraction is smaller. So then you're going to have a calculation that's smaller. So that's why 360 is better than 365 for the bank, is because that fraction is a larger value because it has a smaller denominator compared to 365. Okay, so that's kind of how you can look at the math, those relationships using for money and the calculation of simple interest. We'll do some more examples in the next video. Thanks. Have a good day.